Okay, the next part of evaluating polynomial functions is when are we going to use this, and what exactly can a polynomial function do for you? Well, if I look at the picture here, we've got rings of a honeycomb, and honeycombs are in fact made from hexagons, which are a type of polygon. And so we can use a polynomial function to, in fact, make some predictions about our honeycomb. So if we started analyzing our honeycomb here, we see that the center ring, and you can see that these are in fact rings, the center ring is made up of one hexagon. And so we'll put a 1 in the middle of that one. And then our second ring out, if we count these, is made of 1, 2, 3, 4, 5, 6 hexagons. And so when we've got R sub 1, we've got 1 hexagon. When we've got R sub 2, which is ring 2, we have the 6 plus the 1, which is 7 total hexagons. And then if I continue counting out, I go to my ring 3. Ring 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So ring 3 has the 12 plus the 7 we had before, so that would be 19 total hexagons. And if I go out one more ring, and I count those, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 hexagons in that next ring out. And so my fourth ring would have 18 plus the 19 we had before, which would be a total of 37 hexagons. What I want to in fact show is that this function I have, sum f sum r, would give me how many total hexagons I have for any number of rings. So to do that, we will go through the ones we've already figured. If I put a 1 and find f sub 1, which I don't have listed here, f sub 1 would be 3 times 1 squared minus 3 times 1 plus 1, which would be 3 times 1 squared would be 3 times 1, which is just 3, minus 3 times 1, which is just 3, plus 1. So I do in fact get 1, which is what we needed for our first ring. Now if I look at f sub 2. So f of 2, that would be 3. And I fill the 2 in everywhere I see the r. So here's my r, and there's my 2 r's. So I'm going to fill that 2 in into my function wherever r is. And so that's 3 times 2 squared minus 3 times 2 plus 1. And that's going to be equal to 3 times 2 squared would be 4, minus 3 times 2, which I will go ahead and call that a 6, plus 1. That's going to be equal to 12 minus 6 plus 1. And 12 minus 6 is 6, and 6 plus 1 is 7. And if I look up above, whenever I looked at my second ring right here, I did get a 7, and I've got a 7 with my function. So far, I have shown that this is a good polynomial to represent my hexagonal honeycombs. So let's look at ring 3. Ring 3 would be when we were taking f of 3. So I'm going to fill the 3 in everywhere in my function where there's an r. So I'm going to fill it in both of those places. So that's going to be 3 times 3 squared minus 3 times 3 plus 1, which is going to be 3 times 9, because 3 squared is 9, minus 9 plus 1. So that's going to be a 27 minus 9 plus 1. And 27 minus 9 would be an 18 plus 1, which gives me 19. And if I look up above, my ring 3 was 19 whenever I counted them all up, and my function gave me a 19 also. So again, so far I have proved this completely correct. Let's take a look at ring 4. Ring 4, again, I'm going to go up to my function, and everywhere there's an r, I'm going to take out the r, I'm going to replace it with a 4. So that's going to make it 3 times 4 squared minus 3 times 4 plus 1. And 3 times 4 squared would be 3 times 16 minus 12 plus 1. And 3 times 16 is 48. So 48 minus 12 plus 1. And 48 minus 12 is going to be 36 plus 1, which is equal to 37. And again, whenever I look up above at my ring 4, I do find that we had a 37 up there, and I've got a 37 down here. So it is extremely likely, since I've checked the first 4 iterations of this, that my function is in fact predicting how many rings would be in my, or how many hexagons would be in my rings of my honeycomb. So my final question down here is what happens when we have 20 rings? So that would be f of 20. So I'm going to take 3 times 20 and square it minus 3 times 20. And then I'm going to add 1. So that's going to be 3 times, and 20 squared would be 20 times 20, which would be 400. Minus 3 times 20, and 3 times 20 is 60. Plus 1. And 3 times 400 would be 3 times 4, which is 12. And then I just bring down my 2 zeros, so that would be 1200 minus 60 plus 1. So then I take 1200 minus 60, so that's going to be 1140 plus 1. And so my answer should be 1141 total hexagons when I've got 20 rings.